Okie dokie. So we have got the differentiating powers with negative indices. Now, whenever we have a negative indice, it is treated exactly like if there was a positive indice, okay? And what we're going to do is we're going to be looking at a proof of why this is the case and how it works, and then we're going to look at the shortcuts on how to do it, okay? So let's prove the formula for n is equal to -1. Okay, and we won't worry about proving the formula for all negative integers. However, if you want to have a look at that, you can look at it through your text. So, let's start off with, let's say, we've got, how are we going to do this? We're going to go y is equal to x to the -1. We know this is the same as 1 over x, okay? So, what we're going to do is we're going to let f of x be equal to 1 over x, okay? So then, using our limit form, we've got f of x plus h minus f of x over h is equal to, okay? So what we're going to get is, now I'm going to write this out the long way, we've got 1 over x plus h minus 1 over x all over h like that. So this is the same as, okay, now we're going to subtract the 2. I need to, well, what I'm going to actually do is I'm going to rewrite this as 1 over h, lots of 1 over x plus h minus 1 over x, okay, to make it a bit easier to work with. Now, what we need to do is we need to cross multiply our ones in here. So what we're going to do is I'm going to multiply x plus h over to the right. So that's going to be 1 over h, lots of. So cross multiplying, we're going to get x over x, lots of x plus h, minus x plus h over x, lots of x plus h. Okay, so putting them on the same variable, on the same denominator, not variable, I don't know why I said variable, x plus h, and we get x minus x plus h. Okay, so the x and the x are going to cancel out. We're going to be 1 over h, lots of, now x and the x cancel out. We're going to have minus h over x, lots of x plus h. Okay, what I'm going to do is we are going to divide through, I think. Yep, we're going to expand this out. We're going to get, I'm going to expand the 1 over h, and we're going to get minus h over xh, lots of x plus h, okay? And so the h here is going to cancel with the h here. I'm going to get minus 1 over x, lots of x plus h, okay? So that is if h is not equals to 0. So then if we take the limit as h approaches 0, okay, then f of x is equal to, so I'm just going to expand this out. I'm going to get x squared plus xh, and that should be a 1 on the top, not a h looking thing. I said a 1, not a h. So we've got minus 1 over x squared plus xh, and as h approaches 0, then we get minus 1 over x squared. And that's our derivative. If I then take the negative reciprocal, well, I take the negative power of that. So minus x, lots of -2, which is the result given by the formula. So if we were to use the formula, okay, so that's the long way, the short way, d dx of x to the power of -1 is equal to -1 on the outside, x of minus 1 minus 1, so we get negative x minus 2, which is equal to negative x on, that's bad. We get negative 1 on x squared, like that. Okay, so obviously there's the short way and then there's the long way. We're obviously going to be using the long way in all of these cases. The short way in all of these cases. You don't need to use the long way unless it says using first principles. Okay, if it says using first principles, do it the long way. If not, do it the short way. It's so much easier. So, let's start off by differentiating these. We've got y is equal to -6x minus 5. Okay, so what we're going to do is we're going to take the -5 down the front. and we're going to multiply that by the function less 1 more. So we get that, so if that's y, then dy dx is equal to minus 5 times minus 6 is 30, not minus 30, 30, x to the negative 6, which is, in fraction form, is 30 over x to the power of 6. Okay, and that's it. That's the whole derivative. Part B. Okay, if y is equal to 3 over x to the power of 5, then dy dx is equal to, okay, so what I'm going to do is I'm going to rewrite this as 3x to the negative 5. We're going to take negative 5 down the front. We're going to get negative 5 times 3x, 1 less than that. Okay, and so dy dx is equal to negative 15 x minus 6. And because the power is a negative, then dy dx must be equal to negative 15 over x to the power of 6, just like we had before. So that's how we differentiate powers with negative indices. Okay, what we're going to do next is we're going to do the chain rule for general indices. Okay, so with that being said, I will talk to you guys in the next one.